Thank you for coming over. This time we will do this in English because we have at least one non-Greek speaking person here, which actually I'm super happy about. I would really like this to be in English all the time so we can also share the content with people that are located outside of Athens or anyone who is located in Athens and doesn't speak Greek. Hopefully anyone that looks at the video afterwards, because we're recording it, will have one more incentive to come and visit us here. So as we found out a bit before, there are lots of people here that it's their first time. Thank you very much for coming at Docker Athens. So I will spend a couple of minutes tell you a few words about what this meetup is. So this is called Docker Athens, and if this works, yep. It's the local community here for Docker users here in Athens, Greece. We are active since May 2014. So this year, we're going to celebrate 10 years of doing these meetups. And hopefully we will throw a party or something like that at some point. So stay tuned at our meetup group. And if any one of you here is using Docker in their everyday life or want to use Docker, are having trouble with Docker or having success with Docker or anything, please come up and share these things here. All we do is just share our experiences. To give you a bit of background on how we started, the first company that Antonis, my current business partner, and I started is called Sourcelr, and what we are doing there is an online IDE where it's pretty much like GitHub Codespaces. We started this thing in 2011, and we used Docker, and we wanted to get advice from people that would also use it in 2014. And we didn't know anyone that was doing this in Athens, so we got in touch with Docker, the company. This is how we started this. So this is not a conference. This is not something that you should be super prepared about. Just come and share what you're doing. Actually, what I will do right now here with you, I will share with you a work in progress of what we are doing. This is not running in production, although this was the goal to have it ready until today and running in production, but we didn't manage to do so. So it's a work in progress. I think we have a good demo and we will find out. Things might go south, but we will fix it and it's going to be hopefully a bit interactive after I finish a few slides. So this is it. If you would like to, I think this is where I should point. If you would like to do a presentation here, you can always send an email at hey@docker.gr. And we can also discuss about it afterwards. So think about this a little bit and let's get to the point. If this continues not working, I will switch to the keyboard. So what are we going to talk about today? We're going to talk about how we can set up production grade Postgres with Docker on our servers. So usually we're being told that in production, we should use managed services like AWS, RDS, or Aurora. But we have a few things to say about that, although they're pretty much good. So first thing is that RDS is highly available. But this happens only if you set it up on multiple availability zones on your own. So in case one goes down, you are able to connect to the other one. So this is not something that works out of the box. It's something that you do have to configure anyway. The other one is that Aurora, the more premium service of RDS, let's say, is scalable. But this works only if you do know how to utilize the read and write endpoints on your own and customize your client to do so, or put a proxy in front that can do the work from you. So still, you do have a bit of configuration to do. The other one is that Aurora can be serverless and can do blah, blah, blah. There's no... Anyway, but this is only if you pay a fortune for it to run, because you just want $50 per month in case it doesn't do anything and just sits there if you have predictable workloads. Although this is a great product, and I'm not disrespecting any of these products, they're quite often being oversold, and they might be used for the wrong reasons. And I've seen many people working in DevOps and systems engineering having less and less feeling less and less confident about setting up their own database servers, which is something that we've been doing for the biggest part of the computer science history. So today we will see how we can have a great setup with Docker on our own that works great. So this is what we will talk about. It will be production grade Postgres with logic. So first, we will do all these slides. We will show you how we thought about it, how we have set up the workflow for now, and then we will move on and do a demo where we will see all the configuration files that we have. We will run everything right now on clean servers and have some fun, hopefully. So, agenda. First, we will talk about the requirements. What does production grade Postgres mean? Next, we will see how we set it up. Then we will see how we maintain it. And after we discuss all those principles, we will take a bit of a break and we will come back to do the demo, which means to walk through the whole configuration that we have laid out for this thing and hopefully get this thing working. I'm not sure if it's going to work. I've run it on my own computer. It has worked in the past. We all know how this goes usually, but let's give it a go. Hopefully things will go wrong to make you feel more confident about coming here and doing things on stage. Now, let's talk about the requirements. What do we need? We need for our Postgres setup to be easy to deploy, to be able to scale as our application scales and has more traffic. We want it to be high available. In case things go wrong, it needs to be there. And we need this to be disaster safe from disaster. Let's dive in a little bit in each one of these points and see what does that mean. So first of all, what does easy to deploy mean? For us, it means that there is a single action deployment. Hopefully, all I need to do to deploy my Postgres on my servers is click a button, run a command, do an API call, anything like that. It should be that easy. And the other one is have readable configuration. This is something that we have struggled a lot with existing solutions out there. So I found there's a project called, I think, Cloud Native Postgres out there, which shows how you can deploy Postgres on a Kubernetes cluster to do all this fancy stuff. But it was a hell lot of configuration that I couldn't go and read and understand. And I really do not feel confident deploying stuff that I'm not sure even how to control. Now, I understand that most of these projects are there for a reason, and they are there to cover very high complexity use cases. But for most of us, we don't really have to deal with databases that have to accept millions or even hundreds of thousands of reads per second. So when things are a bit not that stressed, we can take much simpler solutions that can do the job. So for us, and what we will see later, is that readable configuration means 100 lines of code spread into different files. It isn't that much, I guess. Next, what does scalable actually mean? So it means that, first of all, we can have automated connection pooling. What does that mean? It means that every Postgres server can take care of a particular number of connections at any given time. So this depends on the hardware requirements, on many stuff, on the hardware, resources that we already have on the server that it's running on. But it means that it can handle up to X number of users. In case we have many users, instead of using higher resources compute, what we do usually is do connection pooling. This means that we can keep a single connection to perform multiple queries over that connection. This can take place in two different places in our topology. One is the client. We can use connection pooling at the client level, or it can happen at an intermediate level, which is a proxy, which is what we will choose here. And the reason that we will choose to do so is that we can keep the client completely agnostic of whether it's talking to a Postgres cluster, a serverless service, a local Postgres container, or whatever other thing we might have. So we move this to the server level. Then we also want to be able to scale horizontally without our clients noticing. What does that mean? It means that in case we feel that we need more Postgres servers, we need to be able to just add another Postgres server there and be ready to accept connections. So we will see how we will do that. Next here. What does highly available mean? It means that users should barely notice in case a primary server goes down, or they should never notice if a secondary server goes down. What does that mean? When we talk about primary servers, it's a server that accepts write queries, write statements. These are insert, these are updates, these are deletes, and all that stuff. So what happens is that we want only one Postgres server at each time to accept these connections, because this is the best way. Actually, this is usually the optimal way to ensure consistency while scaling. So what happens is that we have one server that accepts both read and write queries, and multiple servers that accept all the read queries. So when a write query comes in a server, it gets replicated to the rest, and the rest are able to serve the rest of the read queries in a load balanced way. So usually in applications, we usually read and not write, and this is something that does the job. So we keep that in mind. So if the primary server goes down, we will have a very brief downtime, but if any secondary server goes down, we want no one to notice. What else? Disaster safety. This is something actually that I wanted to have ready for today, but I don't. But I will tell you about the concepts behind this, and hopefully if we have time, in a bit of a minute, we will do this together. So what do we want to do? So we do have all these servers that run at the same time, and we have the primary server that accepts the read-write queries, and all the other secondary servers that all of them accept the read queries only. This gives us what we talked before about fault tolerance, about high availability. In case anything goes down, the other one can take over, and then we can continue serving our users, our customers. But what happens in case the whole thing gets destroyed? How can that happen? There are many ways that cluster fucks can happen, but let's say that we might have stopped there's a billing issue and the cloud provider just shuts everything down. Let's say there is a malicious person that gets access and destroys the whole thing. So we need to have what we used to call a backup at the old days. So this is what we call disaster safety, and we want to have backup data on remote storage regularly. We want to backup data on remote storage regularly. What does that mean? It means that we want ideally every hour to take a backup of our database, and we might also want to stream the write ahead logs to that storage, so we are able to do point-in-time recovery. What does that mean? As I told before, I've not prepared this for today, but I really wanted to, so I'll take some time to explain it verbally right now. So what is point-in-time recovery? We want to be able to, for a particular time range, to be able to go and create a Postgres database that has the exact data that we had in production at a given time. So this cannot be for the whole time period that our database existed, but ideally we want to be able to do this for the last 24 or 48 hours. We might want to do this because we either lost lots of our data, or because a very weird bug happened in production and we want to replicate the exact state of the database and be able to debug this. So how does this happen? We do the the normal backups every day or every hour or I'm not sure, every company has its own policy according to different stuff. And we take these backups and send them, let's say, to S3, for example. Then, how do databases work? They do have what we call write-ahead log, which is some sort of streaming information about what happens to the database. So what we can do is we can stream those updates to a secondary storage. And what can happen is when we want to create a new instance of our database, we can load the last backup that we have taken, which might be an hour ago, and then also copy the write-ahead log, which is always the last. Let's say we keep the write-ahead log of the last 24 or 48 hours. We can't keep much of it because it's too much of information and lots of time, so we need to recycle it. So after we get the database at an initial state, and then we also supply it with a write-ahead log in the file system, when we start Postgres will automatically replay the write-ahead log starting from the point of the last backup, and then it will reach the point where we want to bring our database. This is super useful, and we want to have this available. Let's go. Let's see how we will set up our system. So actually, before moving on to setup, are there any questions about the requirements that we have for a production Postgres system? Are there any questions about everything we talk until right now? Okay, we'll move on. Let's see how we can set this up. This is funny. So we will break down our setup in two different categories. It's infrastructure and software. In infrastructure, we need at least 2 host machines and private networking that they can communicate with each other. So why do we need 2 host machines? It might be obvious, but actually nothing is obvious or apparent. So we want these 2 different kinds of servers to be on different machines, because one machine might go down for some reason. So we want the other Postgres instances to be on different machines, in different host machines, so they can take over and not be affected by the issues that were caused on the first one. So we want each Postgres instance to run on its own machine, on its own server. And then we want private networking connecting all those machines for 2 reasons. First one is to have a secure connection that we can trust. This is super important. We do not want this to go over the internet, although it can. And the second one is for speed, because usually, not always, but usually private networking is faster than the internet. I know that we can have encrypted connection from Postgres to Postgres all over the internet, and probably it's going to be okay, but there's no reason to do this for multiple servers that are connecting and talking to each other as a cluster, especially because of the speed, because we do want low latency, and we don't want to always have an open channel over the internet where we transfer information. Now, let's move on to the software. So in this particular example, we will use Linux, particularly Ubuntu 22.04, which is the latest LTS version. We will use Docker Engine 25.0. We will use Docker Swarm. In case you do not know about it, Docker Swarm is the clustering option that comes built into the Docker Engine. It's this much simpler version of Kubernetes. And why will we use Docker Swarm? Because it makes it very easy with a single configuration file to schedule each Postgres server on a different machine. We will use Postgres 16, which what it does, it's the latest version of Postgres and actually gives us more replication features and stuff like that. And we will use pgpool 2. This is L and this is 2, the version of 4.3, which is already peculiar that we have a software named 2, but the version is 4.3. But pgpool, what will do is it will sit in front of our Docker containers running Postgres, and it will be the single point of contact that we will have with the Postgres containers. So we will talk to pgpool. Our software will believe that it just talks to a single Postgres server, and pgpool will take care of separating connections, pooling the connections optimally so we can serve more users, load balance the read queries to all the different Postgres servers, and send all the right queries in the primary server, and also promote the secondary server to primary if the primary goes down. I will keep doing this. So, how is this gonna run? What is the topology? We do have the two servers. One is gonna run the primary host, the other one is gonna run the secondary host, and at least one pgpool2 instance will run anywhere in Docker Swarm. So we don't care where pgpool is gonna run, because Docker Swarm can give us a single point of contact, a single domain name, DNS host name that we can use and resolve in the internal private network, and it can reach pgpool2 wherever it is. The great thing about Docker Swarm, in case we have time, we will showcase it, is that we can also have multiple instances of pgpool running. This is much easier than Postgres because pgpool is what we call a stateless service. What does that mean? It means that pgpool does not have any data stored. It only has configuration on how to communicate with our Postgres servers. So in case we want to be even more fault tolerant, we might run multiple instances of pgpool. So in case any of these instances goes down, Docker can take care of just routing our traffic to the other one or other ones. And now, the last part of the first part of the presentation is how do we maintain all that setup? So first of all, we do not want to have a single point of failure for the setup. And for that reason, we want to break out different parts of the setup in different services. So in case anything goes wrong, to not prevent the whole system from running. Why did I put that here? What did I have in mind? So what I did have in mind is the way that we do take backups on our system. What we will try to do is set up GitHub Actions or an external system that can connect on our servers and then take these backups continuously and send them to the external storage. Again, we have not set this up already, so most probably we are not going to see it, but if we have time, we will. We want to set up monitoring for our system. So we want to know when a Postgres server goes down, or we want to know when something goes wrong. And something that we did not plan to have here, but we will prepare for next year because we will need it, is how do we do upgrades? Because part of the maintenance is also upgrading the versions of our databases. And this is usually a pain in the ass, and we want to see how we can take care of it without users noticing. I will give you a brief teaser for that. We've not even researched it a lot, but what we will see today is what we call streaming replication, which works great if you want to have primary and secondary servers that have, duplicates of the data. But this requires these two instances to have the same version of Postgres to work. There's another functionality called logical replication, where we can replicate the SQL queries at the logical level, and this can be used to perform upgrades of Postgres. So we can stream from an older version of Postgres to a newer version of Postgres. And this is the way we can perform upgrades. But this, hopefully, we're gonna present it next year. And as I finished quickly the first part of the presentation, the meetup, I would like to stop here, ask if there are any questions about that, and maybe take a minute, 2, 3 of a break before we dive into the demo, because then we're going to open up configuration and find out if any of these things that I talk about actually works. So any questions about everything that we talked already? Yes?
I want to ask about, first of all, it's a great talk so far. Again,
Thank you.
previous stuff. I have a question about pgpool and the thing that you mentioned about being stateless.
Mm-hmm.
PGPool, I understand that is responsible for actually doing the pooling of connections to the respective
Mm-hmm.
Postgres servers. If there is any kind of a link which I expect to be any kind of a link, how is it completely stateless? How one instance of PGPool
Mm-hmm.
can be aware of another bulk of connections that another PG instance might have? This is kind of what kind of baffles me when you say stateless.
Okay. So I will repeat the question because I do have the microphone here. So the question is, how can PGPool actually be stateless and know or not know of other connections that are in the Postgres servers, right? In order to respect the limits. That's correct. So there are two ways here to do this. The first one is, how does PGPool work? And we will see this. What we do is we create a configuration file that has all the information about where to connect. So there are two ways that you can go and scale PGPool. The simplest one, which is the one that I am talking about right now, is just spinning up more instances. There's another way that you can have PGPool services talking with each other and know that there are more PGPool services. This is done with what they call a sidecar process that runs next to PGPool that's called Watchdog. And what that process is, it makes sure that all PGPool instances connect with each other and have the same information. So I'm pretty sure, though, that there won't be an actual problem of connecting to Postgres, because the amount of connections that it receives, I think it's available through an SQL query. And I'm pretty sure that, actually, I feel confident, I'm not pretty sure, I feel confident that PGPool takes care of that, because you can actually connect to with a CLI. I mean, there are other use cases where you can also connect directly to a Postgres server. So I feel confident that PGPool takes that into account. But in case it doesn't, and it assumes, or you do want to assume, that Postgres instances are only accessed through PGPool, I think the best way to do that is scaling PGPool with configuration, knowing that other PGPool servers also exist. Again, I will say that this is still stateless because this is a part of configuration. It will not need to have an actual block storage device volume where it can store data. This all can be part of the configuration. Which are the Postgres instances that I need to connect to, and which are the other PGPool instances that we all need to know about? Did I answer the question, or? Okay, thank you. Yes?
It's in the same topic, basically, because you also said that PGPool does the leader election. It's the component that decides which will become the master if the master fails.
Yes.
Because in that case, I think, again, they have, if there are multiple PGPools, they have to reach consensus in some way in order to do the leader election.
Exactly. So what can happen there? There are two things. One thing is to have the PGPool instances reach consensus. In this case, you need the Watchdog setup, where you need at least 3 PGPool instances to talk with each other and have Watchdog do the whole thing. The other way to do that is have the configuration for the automatic failover only in one of these PGPool services, which also leaves you with a single point of failure of the automatic failover, actually. But not all use cases are the same, and not in all use cases there are these affordances. But this is correct. There are many ways also to do the automatic failover, but if you choose to do this through PGPool, which is what we will also show today, if you have multiple PGPool services and you want to have 0 single points of failure, this is another thing that you need to take care of. But in this use case, you would also need 3 servers running, because you want the services to be able to reach consensus also in case of a server goes down, and you want this to only bring one PGPool service down. So this, again, it depends on the use case, but if you have proper monitoring and you know that let's say the primary PGPool is down, you can also take action. Yes, I'm done.
Also, what you can do is split the pooling and monitoring. So you can have one PGPool instance just there to make sure it does the failover, and then you can have multiple PGPool just to the cooling. And
I will repeat the answers. So the first question, sorry, I didn't also say the question was how you can have multiple stateless Pidgey instances if they don't, that do automatic failover if they don't reach consensus. That was a question. And another answer given by Antonis here is that you can also split the roles of Pidgey pool. So you can have one Pidgey pool instance do the monitoring and all that stuff, and another Pidgey pool instance doing only the load balancing. Did that answer the question? Do we have any other questions before we go on a short break? Okay, let's go on a short break and come back in 5 minutes to see how the demo is going to work out. I will walk you through our documentation here, our configuration, which serves also as documentation too. And first, we will... Yes, I can. So just, yeah. I think that's the best way to do this. So what we will do is that we will see how I will actually, sorry, let me move to the other. I prefer this window here because it's the first server and okay. Okay. So is this okay? Can you read everything? Okay. Let's go and walk everything through our files here. So this code is not available right now online, but we will give you a link afterwards that you can use. And in a few days, hopefully sometime next week, certainly within the next 10 days, we will have there some great code available for you to use. Now, let's go and see how the setup that we talked about before can be done with Docker. First, after we see all this configuration, we will make this run on this machine that we are right now, which is on Hetzner. And after this works successfully, we will also rerun this on the Docker Swarm cluster that I have already set up and see this working on multiple machines. Let's go, let's do this. First of all, let's open up the Docker Compose YML file that we have here where we describe all of our setup. I think it's the best place to show our topology. Now, first, in case you don't know, actually, let me say a few things about Docker Compose. Docker Compose is a tool that accepts a YML, a YAML file as input, and then it lets us spin up multiple containers with a single command. This matches with what we said before, that we want to be able to run our setup with a single command. And our command is Docker Compose app in this case. And this is how it works. This is a YML file. There we describe a base configuration, which also has an indentation issue that I will fix right now. Much better. So we do have some base configuration that we can reuse later. This is what's called YML anchors and Docker Compose extensions. So we will use this configuration for both our primary servers and our secondary servers. And we do this because we do not want to repeat ourselves. We want to reuse as many things as possible. So what do we have here? The command of our containers that will be running Postgres is Postgres-c-log statement equals all. What does that mean is run Postgres and also log all the statements that you will receive in the command line. We do this only for debugging purposes so we can see that everything runs. What do we do here? We say that the Postgres password file is in /run/secret/postgres-password, which is where Docker will load the secret with the password of our Postgres database. And we also have another environment variable called Postgres CIDR, which is the subnet address space where the Postgres servers will run. What we talked about before is that we need, in part of our infrastructure, a private network where all the Postgres instances can communicate with each other. In order to be able to set up correct access to our Postgres instances, we need to know the address space, the range of IP addresses that all these Postgres instances will be available. And this will be this exact address space, which is 172.54.32.0. So next, let's go and see how we set up each one of these servers. And we will see also how we will ensure our services will get these addresses. Now, we do have three services, as we saw before. One is the primary Postgres server, and the other one is the secondary Postgres server. And last, we have pgpool, which will be the one sitting in front and the one that we will be talking to. The primary service starts off from our base configuration. It builds the Docker file in the root directory, and it targets the primary build target. What does that mean? In Docker files, as we saw also in the previous presentation, which in case you weren't there is available online, both the slides and the video, and you can watch, we can have multiple build targets in a single Docker file. This is very useful to avoid complexity in some cases and make things simpler. We will see how that looks like. And we do have a volume that says that there's a volume named primary data that I want to have available at /var/lib/postgresql/data, which is the default directory where Postgres stores data. Now, we also have a secondary Postgres server as a service here, which has a few differences. The first one is that it targets the secondary build target in a Docker file that we will take a look in a bit. And also it has a restart command on failure 3 times. Why do we do that? We do want our services to we want our setup to run in a single command. When we try to run this, the secondary server will fail. Why will it fail? Because it will try to connect to the primary server, which is setting up itself at that moment. So we want to have a restart policy here where it can try a few times. This wouldn't be an issue with Docker Swarm because when we say I want to run a service, Docker Swarm always retries running that service no matter what. And then it has another volume named secondary data where it also is being mapped in /var/lib/postgresql/data. Okay, let's move on. Third service, pgpool. Nothing but building the target pgpool in the Docker file here. We also have some secrets which are being sourced from some files in this repository, and they are being made available in /run/secrets in our Docker containers. This is what Docker does automatically. With secrets, we do have our volumes here. So the volumes that we're mentioning above, they need to be also declared as a top-level volume in Docker Compose because they can be reused in many services. And last and most interesting part is the networks. So in case we do not declare a network in our Docker Compose file, Docker Compose assumes there is a default network running. So if we go and declare a default network with some configuration, it's going to override the default configuration with anything that we will put here. So what am I doing here? I am declaring the IP addresses that I want my Docker containers to get assigned. Why do I declare my IP addresses? Because as I saw above, I need to know the CIDR, the IP range of the Docker containers, so I am able later to set up appropriate access to our Postgres servers. So we have everything there. We have the containers, the services, we have the secrets, which are being sourced from files. We can see them, they're just development passwords and stuff like that for here. We do have our networks where we have the address spaces that we need And lastly, we do have our volumes where we declare that we need to store our data. Before we move on to see the Docker file, does anyone have any questions about the Docker Compose file that we saw right now? Good. Let's go and see the Docker file. I will split screen here. No, I do not want to install. So, what do we see here is that, sorry, just a sec, just to scroll a little bit. 3 services. First on primary, the context is the current directory and the target is primary. So from Dockerfile, I have a target named base. The only reason I do have this target is just to reuse it wherever I need Postgres. So everything I do here is I pretty much rename locally the image Postgres 16.1 as base. And then I go and say from base, create a primary target where all I do is I copy the entry point files from the primary subdirectory in my repository into the appropriate repository inside my image. So how do I know how to do that? I actually go to the documentation of Postgres 16.1 and see the instructions on how I can initialize my database. So if I go and command click here, it might, no, okay. I hoped it would autocomplete it. Hub. So if I go here and see entry. So here, if I go to all I did was go to the documentation and see how I can set up initialization scripts. We will not read the documentation here, but all it says is that you can put your scripts in that directory and then I'm going to initialize things. Let's go back here. In my secondary target, all I do is I copy some binaries into USR local bin and I change the entry point. So what is the entry point? In case anyone doesn't know here, the entry point is the command that I want my Docker image to always run, no matter which command I will add after Docker run. So usually I say Docker run, I say the image, and then I indicate which command to run. So if I have declared an entry point, what will happen is that it will run my entry point no matter what command I will declare later, and it will pass my command as arguments to the entry point. This is great if you need to initialize data every time you run a container, no matter what the command is. So because when I start my secondary server, I need to copy the data from the primary one, and I need to do this at start time, I needed to change the entry point, or else I would need to create a new entry point and tweak it, and I didn't actually want to do so. And then I also set the command to Postgres by default, which is being unset every time you set the entry point. So I just set it again, which is pretty much mundane because in any case, I override it here in Docker Compose. But I wanted to be neat and tidy, so I did this. And the last one is pgpool. Unfortunately, pgpool does not provide official images for Docker, so all I did was go and read the documentation to install it on Ubuntu and blah, blah, blah. I just copy and paste stuff here and did this. I know I can do much better building techniques, but it's easier to read for this demo, so this is how it goes. And then I copy all the configuration from the pgpool2 directory into etc pgpool2 in my container, and I run pgpool in the foreground. And last, I just say, in case I don't declare, there is another from primary here. In case I don't declare any build target, primary is the default because I just say from primary last. And what I do want to point out here is that all the configuration of pgpool2 is right now static. because as I said before, this is a work in progress. And if I did run this in production, actually, when we do run this in production, this configuration will be generated at runtime when the container starts through an entry point based on secrets and environment variables. But for the sake of this demo here, this is completely hard-coded. Let's go and see the configuration one by one. So we saw the Docker Compose file, we saw the Docker file. Let's go and see the rest. So first, as we saw here, there's a directory named Docker entry point initdb.d that we copy every time. So what do we have here? I will close this, move this here. So what are we looking at right now? We're looking at the initialization scripts of the primary server. So what do? I create a variable named replicator password, which takes its value from the secret replicator password in my container. This secret is being automatically created because I declared in my Docker Compose file that I want to use that secret. And then I run a command in Postgres where I create a role named replicator, where I give it the replication permission, and then I set the password, which takes its value from here. So first thing I do is set up the replication user. Now, all my secondary servers can use that user to perform replication on my machine. Next, what I do want to do is I want to add an entry in the PG HBA conf to declare how are other clients able to connect to my Postgres primary instance. So besides creating a role that has these rights, I also need to say to Postgres to accept connection from particular addresses for particular operations. So what I'm doing right now is that I'm saying that you should accept replication connections from the replicator user from that address space. This is where I use that exact setting that I needed in my service using the Scrum SHA-256 authentication scheme. So there are many ways to connect, to authorize your Postgres connections. So for example, you can say to Postgres that if you connect from localhost, don't ask for a password, because if someone has access to localhost, they pretty much have access to anything. But because we need these servers to be on different machines, these Postgres instances, I need to be more strict about how I accept connections. And I append this line of code in the file pg_hba.conf, which is the file that Postgres uses and automatically generates to declare to consult on how to accept connections from different networks and for different operations. So this is all I need for my primary server. I just need the stock Postgres image, create a role so that I can replicate and allow network connections for replication. That's it. I think it can't get much simpler than that. Are there any questions about the primary server here? I don't want to intimidate you about what I said about simple, but I believe that it's really decent on doing this yourself. Any questions about setting up the primary server right now in Postgres? Okay, let's move on to the second one. So what we did see in the secondary server, I copied some binary files, which are shell scripts actually, and the custom entry point. Oops. Let's go and see the entry point first. What do I do here? First, I check if the file pgdata pgversion exists. If this file exists, then Postgres has been initialized. If it is initialized, I do nothing. If it's not initialized, I say so. And then I run these scripts as the Postgres users, which is take base backup, enable the standby mode, which means that I'm only accepting read-only connections, and then configure how I can pull data from the primary server. Let's go and see each one of those scripts on our own. So I will open this first. What do? I export the variable PG password, which is needed by Postgres, so it performs connection without asking me for password. I don't want it to ask for password because this is running in a non-interactive terminal as a container on my server. So I just cut the replicator password, which is the password I will use to connect to the primary server to take my data. And then I will run PG base backup to pull an initial state of data from the primary server. And then I will do this using the replicator password and with a few other options that don't matter that much. And I will set the appropriate rights to the PG data directory, which are not always set, and I have not debugged why yet. Now, after I take the base backup, I will go and just create that file named standby.signal. If Postgres finds that file, it configures itself to be in read-only mode and just accept data. And then lastly, I will configure the primary server. So what I'm doing here is a bit peculiar, but it's the cleanest way I found to actually perform Postgres configuration a bit dynamically. So what's the issue that I'm running into? I have just pulled the data from Postgres. So right now I do have files there. And all I want is just to alter the configuration, which is and should be the same with the primary configuration. And why is the same? Because I pulled it in the first step with base backup, and I just want to add an option to my configuration to know where to pull data from, which is called primary con info, which is a connection to the primary server. So the way I don't want to create shell scripts that are really hard to read and edit the configuration file and shell and do all that thing. And I found out that you can just write an SQL query and then Postgres will go and create that configuration for you automatically. So what do? I run pgcdl, I start Postgres, I do -w, so I wait for Postgres start to be completed. I run this command, which I do alter system set, and I say, where is the primary server actually located? Where I'm using the host primary because Docker will just give this DNS name internally and I can use it and I don't need to know the IP. I know the passwords and all that stuff. After this is completed, I stop Postgres. And this is it. After this, at the end of the day, I'm running docker entry point.sh, which is the default entry point of the Postgres image, using the parameters that anyone supplied there. So that's it. This is how the secondary server works. It initializes the data, it creates a standby signal, and then it configures the connection to the primary server, and that's it. Do we have any questions here before we move on to see pgpool 2? Okay. Yes?
Is there any point in having many secondary
Servers?
no servers, like instant, like images in one server?
So the question is if there's any point in running many secondary images on the same server, right? I don't think so. I would run many secondary on that equal many number of host machines. This is what I think is the best way to do this. Because why would you run it on the same server? To take advantage of more CPU cores, maybe. But you can just scale vertically the container to give it access to more CPU cores. So there's no reason to add that network complexity, because at the end of the day, each container gets its own IP address. There's no reason to add that same complexity there if you don't take advantage of having a separate host with one less point of failure and its own disk. Because also, if you do run that on the same host, you suddenly have half the space available for each Postgres instance, because you have two containers running on two different volumes, because you don't want them to run on the same volume because everything is going to be corrupted. Any other question before pgpool? Okay. Let's move to pgpool. What do we do here? We do install pgpool and we copy the configuration from pgpool to etc pgpool2. So there are a few files that we need to take a look at here. First one is pgpool.conf. I will do a quick walk through this code because this is the biggest file that we have in the whole configuration. So all I'm saying is that I'm using streaming replication here, so pgpool knows that we are replicating pretty much binary data. I'm saying which address I'm listening into, to which address PCP listens to. But what is PCP? PCP is a separate process that I can use to check out the health of my cluster. I add here information about my backend 0, which is the primary server. Then I add information about backend 1, which is the secondary server. I enable authentication with password. I log all statements because I just want to debug. I enable load balancing mode, so it will load balance connections to all servers, but will send write queries only to one. Then here I am adding some streaming replication checks, so it can also check how is my replication going, so I can ask pgpool, are the two servers in sync? And it does know. A few health checks so that it knows everything runs greatly. And here is the last and most interesting part. What I do here, everything is hard-coded, but in a production scenario, this would be generated at runtime, is the failover command. What does that do? When a server fails, which is after 3 fails with 10-second delay after every 30 seconds, it will run the failover command. What is the failover command? It connects to the secondary server and it runs PSQL here and runs one query named pgpromote. So what this does is, in case the primary server vanishes, after it decides when it needs to fail over, which is a setting based on the health checks here, which everyone should configure according to their application and affordances, it will promote automatically the secondary server to the primary server, and then it will be able to accept write connections. Then we do have the PCP configuration, which all it has is a username and a password in MD5 checksum. So this is the username and password that I will use to check my servers. And what else? This is a file that I just kept because I wasn't confident enough. But anyway, here I allow connections to my pgpool instance from all network interfaces using the Scrum SHA-256 authentication scheme. And here I do have a password for a user named Postgres. In plain text, you wouldn't do that in production, of course, and named development_password. And this is it. We should be able to run our tests right now, if you're ready. So I will make a pause again to say, do you have any questions about the setup, about primary, secondary, pgpool, Dockerfile, Docker Compose? Do you have anything to ask before we go and run all these? Okay. We either have lots of things to ask, or we're already in a good state. So I'm here in that directory, and I will run Docker Compose up. Let's see how that works. I've never run this on this computer, but it's on Hetzner and hopefully it has great network. So because I have different build targets, Docker build will hopefully, and I think it does, yeah, it runs these in parallel, so I don't have to wait for each build step to complete before I start the next one. As you can see, the image for the primary and secondary is ready. Everything we see, okay. Okay, yeah, let's go back. Everything is running. So pgpool started, the secondary started. It couldn't connect, as you can see, on the primary server because the primary server has not started. The primary server started here. The secondary restarted, tried to reconnect, but the primary server was not ready. The primary server is ready. And now the secondary server, did it retry? Yes, it retried one last time and then it worked. If we go above, we can see our scripts running, setup replication auth, all our scripts are running. Same here, all our scripts are running in secondary. The secondary server started running PGBase backup and started accepting connections from the primary server. And after all, our system has reached a stable state. And as we can see here, there are many queries being run in our applications. These are being run by pgpool, which continuously checks the health status of our applications. So I will grab my computer right now because I will need to do a few more stuff and see how this works. So Docker compose PS. So we have 3 containers running, pgpool, primary, and secondary. Let's go and run. Let's actually start another here. Let's put this here. I will go first. I will do Docker compose exec primary PSQL u Postgres. So I connected to the primary server right now. This did not ask for password as you saw because it runs in localhost and uses the trust authentication scheme, not the Scrum SHA-256 because it's trustworthy because of localhost. Below, I will do the same, but for secondary. So let's write some SQL. I will admit that I have forgotten most of my SQL, so I will copy and paste most of the stuff. So let's run select star from people. Nothing. The same here. Let's go and create that table. Here, let's see if I can rename this. No. Below is the secondary server, above is the primary server. Let's go and open our SQL file. I will go on the secondary and I will try to create the table. As you can see, it does not let me because the secondary server sees the standby signal file and it knows that it only accepts read-only connections. So here I will run create table on the primary server and it works. Now, when I go and I do select from people, it exists on the secondary server suddenly. So what I will do here is there's a great command in Postgres named watch1. So it will run the last query every 1 second. So I will go and copy and paste. I will copy Antonis first. I don't want to be that much of a narcissist. So let's go here and insert Antonis into the table people. As you can see, it replicated to the secondary server below. Let's go here and let's do here. It needs this. So replication works, as you can see. And of course, if I do select that here in the primary server, it also works. Now, I want to see if pgpool actually does the load balancing for me. Let's go and see. I will open a new, I think it's better to start a new server. And how should I do that now to make that easier? No, I decided. I will open up a new terminal. I will bring this here. and I will open up a new one, split the screen here. Yeah. What will I do? I will run docker compose exec pgpool u Postgres. Yes, of course, I need to run PSQL. And again, I signed into pgpool. Here, I will run select star from people. As we can see, as much time as I ran it, it always ran on the secondary server. Why does that happen? This happens because we have connection load balancing, not statement load balancing, which is the best thing if you don't do your own connection pooling. But if I exit and I run the command here from the command line, because every time the PSQL CLI connects to pgpool, it's a new connection, I will see this load balancing right now. Oops, sorry, I need to scroll down. I spammed it. So if you see, we can see almost equal logs of primary and secondary. Here, it might be a good idea to post the logs at some point because I know it's hard to follow, but believe me, it's load balancing it right now. And what we will see also after I connect again is that I am able to run both read queries and write queries. So I think it will be interesting if select star from people. So where did it run it? Let me see. Did it run it here? Yeah, it ran on the secondary. So no matter how many times I run this, it will run on the secondary. If you see, I mostly see secondary logs here. But if I do an insert here, the insert will be automatically be routed to the primary. If you see, the primary run the insert query. So pgpool, even though is putting all read statements to the secondary, it directed the write statement to the primary. This is pretty amazing. And what I was saying to Antonis before we came here, it's really amazing that I was able to put out that demo that quickly, because that was almost a day of work, which is really, really not a lot to do a DIY thing. And it's mostly because the Postgres and pgpool and Docker developers are so amazing. So I just wanted to say this. Now, another thing that I would like to see is how would that system behave in case something went wrong. And so what am I going to do right now? I will go to a clean terminal, and let's see. What should we do? I will open a new one. Too many terminals, but never mind. I will go and exec inside pgpool, and I will use that software called PCP, which we saw very briefly before the configuration for, which is a command line interface for seeing the status of our cluster. So I will do docker compose exec pgpool bash and PCP, how's that? Node info. Yeah, that should be it. And it should be verbose host, localhost, port 9898, u Postgres, and the password I think is development password. No? Come on. I will open the password here. Never mind. Yeah, so what can I see? I have the primary server. Here is the weight in the load balancing. Here is its status, app status, primary role, no replication state. Why? Because it does not replicate. And the secondary is up again, same weight. So randomly the request should go to one and another. And the replication state is streaming with yes and with async method. So it doesn't actually wait for the write to be completed, but it does this in an asynchronous way. In case you want to be super careful about consistency, this better be synchronous, but it's going to have a bit of a lag. Now, what should we do? Let me think about it. I will bring this here. I changed my mind. This happens all the time, I need to tell you. And what I will do is we will we will Docker compose stop primary. Let's see what happens. I stopped the primary server. Let's see. As you can see, I asked for the status and it's down. Now, let's write here Docker compose logs tail 0 f pg pool. Here we will see the logs of pg pool, and what it does is it fails to connect to the primary server, as you can see. Let me see how much can I wrap this. And after some time, how much time? It's going to be 30 seconds plus the delay 3 times. We will see many kill statuses here, and it will run the failover command. And this will promote the secondary server to primary, and I will be able to continue doing my writes. Hopefully this is going to work. You understand that this is a live demo, so it worked on my computer. Famous last words. Let's see how that works. Okay, I see many child processes here. Let's retry the status. Yeah, there we go. So as you can see, the primary server is down. That's it. And the secondary server has been promoted to primary because we ran pgpromote on the automatic failover command. I'm super happy about this. And the replication state is none. Why is it none? Because it's not replicating. Why it's not replicating? Because there's no primary server to replicate from, and it was promoted to primary. So we had about a minute of downtime here, and no one ever barely noticed because it's 4 a.m. and we are at our bed, and next morning we do have to get our things working. So what I will do right now as a last step in this whole thing is I will go and exec into the secondary server. I will run PSQL there, and I will try to do a write query directly on the secondary server. Let's go and see how that works. Let's bring this here. No reason to do the split screen thing. Docker compose exec secondary pass. So first of all, if I go and list files in varly PostgreSQL data, there is no standby signal. If you remember, in our initialization scripts, we would create that file. We didn't verify it, but it worked. So believe me, it was there. And it was removed when we ran pgpromote. So now PSQL u Postgres. Select star from people. Everything works. And also I will do an insert, which will also work. It worked. So I have my secondary server working right now. The only bad thing that, not say bad thing, but the only thing that we did not do right here is we didn't get our things working on multiple machines. So do we have 5 minutes to give it a go? Okay, so I will try and showcase how we could also run this on multiple machines right now. Before I do that, are there any questions about everything that happened? Yes, there are two questions. First one.
I want to know if we...
Yes, that's a great question. I will repeat it. What will happen if we restart the primary server? Absolutely nothing. Why? The primary server will still believe that nothing happened, that I restarted and I'm here to accept connections. But pgpool will not automatically send any queries to the primary server. Why? Because it has promoted the secondary server to primary, and if it would so, we would not have data consistency, because suddenly write queries would go to a server that's out of date. The data now are on the secondary server. So I hope that would make a slide for that. So great question, thanks a lot again. And I will say that what I would do in that case is I would start a new server from start and make this the secondary server. That's what I would do. It's the simplest thing. That's one of the things that you can do on the cloud. You can just, something that yesterday was a secondary, now is the primary, and everyone is happy. So this is what I would do. Any other question? Yes?
On the same topic again, because although they're explicitly named primary and secondary in the Docker file,
Yes.
Composer, how would it be possible to just start a secondary with like same name, and how would this work out with no downtime?
So how would this work out without downtime? So naming them secondary and primary is definitely something I did for the demo. The best thing you have to do is name them server 1, 2, 3, 4, 5, 6, and never know if they are primary or secondary servers. So what can happen is that now server 2 is suddenly the primary, and you just create server 3 with the appropriate configuration. That's it, how this would work. And it would have the secondary configuration. That's everything. Any other question before we try and do this on multiple servers? Okay. Yes, it's actually the same process as we said right now with bringing the primary back, which is something that I wouldn't do. I would just add a new secondary server. So all you have to do is create a new service based on the secondary configuration and just create the new configuration where everything can talk to each other. I mean, you would need to do two things. You would need to create a new secondary that would stream from the current primary. You would need to allow replication in the current primary, which is something that you have not done, and we need to do this by hand. Maybe we can do this also with the automatic failover, but you know it can get a bit weird. So you would just load up a new secondary server that just listens to the new primary, and that's it. And you can do this as many times as you want. That's it. Five minutes or not?
20 minutes, including the beers. So I would suggest that we do this with the beer.
Okay. Let's do this with a beer at hand. Thanks a lot, everyone, for being here and for your time and your questions. Let's go and grab some beer. We will stop recording right now, and I will leave my computer here. Thankfully, it had enough battery. I was more afraid for it than I should. And let's go back to the slides a bit. Yeah. So if you go to that repository, it's github.com/with-logic-co/Postgres. There is where we will post all of the configuration that we will be running in production for Postgres. The repository exists. It has a README file. You can start it, you can watch it, and by the end of next week, it will be there because, as you saw, we do have some decent things happening here. I see many didn't expect people writing this down, but yeah, thank you very much for doing that. What we will have there is a README file on how this whole thing works and how we've thought about it. There will be a Docker Compose file that you can run locally to test this setup. There will be a Docker Compose file that you can use to deploy this with Docker Swarm. There will be public Docker images that you can just pull. You won't need to build any of these images to run that thing. And there will also be some reusable GitHub actions that you can use to try and automate all this stuff. So make sure to go there, start this repository, and we will also post all these things at the meetup page to make sure you have them available. Thanks a lot for coming. Our company, Logic, is doing a few things. One of those that we are very proud of putting much love on it is working with DevOps. This is why we did this presentation here. In case your company needs help with DevOps, we can help you. You can just go to withlogic.co/docker or hey@withlogic.co and reach out and share with us your DevOps problem, and we will be more than happy to help. So thanks a lot for coming in. Let's go and grab some beers, and anyone who wants, we can try the Swarm thing later. Thank you.